All right, so let's look at the substitution rule. Now, if you see this any other place, substitution, there we go. Rule. A lot of times you'll see it as the U substitution rule. So, like let's say you get stuck and you're looking for some help, but you're not getting a lot on substitution rule. Try U substitution rule, and you'll generally, that's just another name for it. So, okay, all that we're doing with the substitution rule is we're just doing the chain rule backwards. So, like with the chain rule, we're looking for these composite functions. So if this is a little bit tricky at first, don't worry. For most people it generally is, but it's just one of those things, the more you practice and the more that you start to look at these things and you work with them, the easier it's going to get. So if it's hard in the beginning, don't worry too much. All right, so let's take a look at this just by a few examples, because that's generally the easiest way to learn how to do it. So let's say we have the integral of 2x times x squared plus 1 squared dx. Now looking at this, we might say, oh, okay, well this looks like we have a composite function here. So what happens if over here on the side we're going to, instead of this x squared plus 1, we're just going to say that's u. Okay, so well, if that's u, let's figure out what the du is going to be, the derivative of this. So the derivative of u is going to equal, well, that's just 2x, and then we're also just, for now, put dx over here. So the derivative with u is going to equal 2x and then dx. All right, so now looking at that, let's move this back over into here. So I substituted this as my u. So I'm also gonna kind of reorder these just a little bit. So this is u, so all I have is I have u squared, and then I have my du right here. See that my 2x and my dx, so that equals du right here. So because of that, then I say, well, okay, I have both of these parts. So I'm going to call this u squared du. Now, lo and behold, this is what a mess, right? You can't really do much with this, but we know what the integral of u squared is. So let's go ahead and write that out. The integral of u squared is going to be u cubed. Remember, you add 1, then divide it by whatever number you have up there, and then plus some constant c. Well, all right. Just the last step now, we have to substitute this, because we're looking for it with respect to x, back in. So we're going to have x squared plus 1 cubed over 3. There we go. And so, oh, don't forget plus c. And the nice thing about u substitution or integrals in general is you can check it by, if you took the derivative of this, you should get that. Okay, so let's go ahead and take a look at another example here. So this will be, let's move it over a little bit to give us just a little bit more room. So let's say we're going to take the integral. Let's do one of these ones, because these can be a little bit complicated. So 2x minus 1 dx. Okay, well, the same thing here. Looking at this, I say, well, whatever's underneath here, let's try making that u, because we're looking for these composite functions. All right, so if I make u 2x minus 1, then my du is going to equal, well, that's just 2, right? Derivative of that is 2 dx. Now, looking back over here, I see that I have a square root of u here, but there's no 2. Now that's okay, because we can sort of work around that by multiplying it eventually by a constant. But the way that I like to think of it is I need to figure out what dx equals in terms of u. So that's easy enough. I just say, okay, if I'm solving for dx, I would just divide each side by 2. So I know that dx is going to equal du divided by 2, or 1/2 times du. All right, so now let's go ahead and come back here. So I'm going to rewrite this then. This is going to be the square root of u times 1/2 du. Now, the really nice thing about these constants is I can just go ahead and move this out to the front. So let's rewrite this one more time as 1/2 the integral, and I'm just going to call this u to the 1/2 du. Now, good. We're at a spot again where we can take the integral of this. We know what it's going to be. So, just like before, this 1/2 is going to stay out here. And then we're going to add 1 to this. So that's going to be u to the 3/2. And then we're going to divide it by 3/2. But dividing it by 3/2, that's going to be the same as multiplying it by 2/3. Just because that's, again, we're taking the reciprocal. So we're doing the same thing. We're dividing it by 3/2. I'm just sort of skipping a step and saying, well, we'll multiply it by that. All right, so, don't forget, plus c. So we have some constant there. Okay, we're getting close. Let's combine this fraction. So I've got 2 times 1 is 2. 2 times 3 is 6 times u to the 3/2 plus c. So then let's just simplify this down. So this is going to get me 1/3 u to the 3/2. And then now let's just substitute u back in here. All right, so up here, u is 2x minus 1. All right, to the 3/2 plus c. All right, there we have it. Okay. So as you can see, they're they just take a little bit to get used to. Let's take a look at one more example that generally can be a little bit tricky. And just as a disclaimer on this one, there is a chance I might make a mistake along the way because they can get fairly complicated. But let's go ahead and dive in. So in this one, I'm going to have a rational expression. We'll do x over the square root of x minus 4 dx. And I believe this is one of the problems from the book, so you can kind of verify the solution. So, okay, so in this case, well, let's go ahead and let's focus in on this composite function right here. Let's say I'm going to say that u equals x minus 4. So then du, the derivative of x, well, that's just 1. So that's going to be 1 times dx. All right. Now, looking at this, I have my dx there, so that's good, but I got this x up here. So what do I do with that? Well, I come over to this up here, and from this, I know that if I solve for x, well, if I add 4 to each side, I know that x equals u plus 4. All right, so I come back over here, and I'm going to rewrite this as u plus 4 over the square root of u du, because du equals dx. All right, now let's simplify things just a little bit. So let's make our lives a little bit easier. I'm going to break this up. So u divided by u to the 1/2, that's just going to equal u to the 1/2. Plus, I'm going to pull out this 4 for integral u to the negative 1/2. All right, so you see all I did is I separated this out. It's one fraction now. I separated it out into 2 fractions. Okay, and don't forget the du's. I sometimes forget to write those. Okay, so but now we're in a good spot, right? Because we can take these integrals. We know what these integrals are. All right, so let's see. We're going to have over here, we're going to add 1 to each side. So that's going to be u to the 3/2, then times the reciprocal, because remember, we're just dividing it by 3/2. But yeah, so that's plus 4. Then the same thing, we're going to add a half. So that's u to the 1/2 times 2. That's just these. All right, so let's simplify this a little bit. So the first one stays the same. It looks like 2/3 u to the 3/2. 4 times 2, that's plus 8 u to the 1/2 plus c. All right. Well, now looking at this, oops, my paper got a little bit confused. Really, all that we're doing now is it just comes down to a little bit of algebra. I can factor out a u to the 1/2 out of each of these. So I'm going to factor that u to the 1/2 out. So I've got u to the 1/2. And I'm going to multiply it by 2/3 u. Is u to the 1/2, so that's just minus a half. So that leaves me 2/2 plus 8. Okay, so at this point, let's go ahead and substitute things back in, and it's going to get a little bit hairy for a bit, but don't worry, it'll work itself out in the end. So my u is x minus 4, so I've got x minus 4 to the 1/2. All right, so then I've got 2 times x minus 4 over 3 plus, and then just for simplicity, I want to eventually make these into just one fraction. So that means that I'm going to combine, or I'm just going to make this denominator 3. So 3 times 8, that's 24 over 3. All right, so again, have no fear, even though it looks kind of bad. All right, so diving in here, this is going to become, the front stays the same. All right, so I've got 2x minus 4 plus 24 all over 3 plus c. Okay, so here we go. The front stays the same. X minus 4 to the 1/2. Let's break this down. So I'm going to have 2x stays 2x minus, let's see, so I got negative 4 plus 24. So that is, oh, whoops, that should be 8. I'm sorry. Oh, there we go. I knew there was going to be a mistake in there somewhere. All right, so that's minus 8. So then I've got 2x minus 16. 3. Okay, oh, we're getting close now. All right, looking at this, I can take 2/3 out of each of these, right? I can take a 2/3 out of that one, and I can take a 2/3 out of that one. So this is going to get me to x minus 4 to the 1/2. Oh, there, yeah, let me get it there, 2/3. All right, so then that's going to leave me with, all right, take a 2, so that's x minus, let's see, 8 plus c. All right, so look at, oh, that's not going to be minus, that's a plus, I'm sorry. So there's the second mistake. All right, so that's a plus. All right, but, oh, we are getting so close. All right, so now I can just rewrite this, make it look a little bit cleaner. X minus 4 to the 1/2, x plus 8 plus c. Woo! All right. So as you can see, and with a lot of this integrals, and with all this, the majority of the work really, once we got to like right here, right here, I mean, we had a good answer. We could just substitute this back in. But the majority of the work, at least the more difficult stuff sometimes, can be just the algebra. Because then, once we got to a good answer here, this whole bottom part is just simplifying. And as I sort of exhibited, you have to be really, really careful, because even something small like changing a sign around can be sort of detrimental later on in the equation. So that's U substitution, the substitution rule.